Hello everyone. Before diving into today's topic, we want to take a moment to thank you for your support. Every like, comment, and subscription truly makes a difference and helps this channel grow. If you enjoy our content and don't want to miss upcoming videos, subscribe to the channel and turn on the notification bell to receive all updates. What happens to planets when their parent star reaches the end of its life cycle? Could they simply vanish into nothingness, or silently dissolve? Or might they face a far more dramatic fate, being torn apart and scattered into space like fragments of an ancient forgotten civilization? This is not science fiction, but a real possibility, a phenomenon that may have happened to a distant planet whose remnants continue to send signals across the cosmos. For over 40 years, astronomers have been trying to unravel a mystery hidden within the Helix Nebula, one of the most fascinating in the Milky Way. In 1980, the first X-ray telescopes detected an anomalous signal coming from this region of space, something unusual compared to the emissions typically observed in white dwarfs. This mystery has stood the test of time, with missions like Einstein and Rosat continuing to record strange variations in radiation. Only now, thanks to the most advanced instruments, are we beginning to find a concrete answer. At the center of the Helix Nebula lies a white dwarf called WD 2226+210. This stellar remnant normally emits X-rays, but at a surprisingly higher intensity than other similar white dwarfs. However, what has puzzled astronomers is the cyclic nature of its emission. Every 2 hours and 9 minutes, a regular variation in radiation occurs. A signal so precise could not be random. Something was orbiting the star, interacting with it in a way that altered its brightness. Initially, scientists hypothesized that the cause was an accretion disk, made up of dust and gas from comets, or small bodies originating from the Kuiper belt. However, this explanation was not sufficient to justify the observations. Scientists then began to consider an even more extreme hypothesis. The signal could be the remnants of a destroyed planet. Analyses conducted with data from NASA's Chandra Observatory and ESA's XMM Newton telescope suggest that the white dwarf may have captured a celestial body the size of Neptune or even Jupiter. This planet, which once orbited far from its parent star, could have been drawn closer due to gravitational interactions with other objects in the system. As it approached, its fate was sealed. The white dwarf's tidal forces began stripping away entire layers, ultimately breaking it apart completely. This destruction left clear traces in astronomical observations. The X-ray radiation emitted by the white dwarf shows anomalies compared to other similar stars, and the same is true for infrared radiation, which exhibits significant variations. Space debris produced by such events is not uncommon in the universe. Some theories suggest that similar processes may have occurred even in our own solar system. In our solar system, there are celestial bodies whose origins remain uncertain. A prime example is the asteroid belt between Mars and Jupiter, which some scientists speculate could be the remnants of a planet that never fully formed or was destroyed by catastrophic impacts. But what does this phenomenon tell us about Earth's future? Let's imagine for a moment that our planet undergoes a similar fate in billions of years when the Sun reaches the end of its life cycle. During its expansion into a red giant, the Sun will engulf the inner planets and then collapse into a white dwarf. At that point, Earth could experience destructive forces similar to those observed around WD 2226+210. Its atmosphere would be stripped away, its oceans would evaporate, and its crust could be progressively reduced to debris. This is not just theoretical speculation. Studies on white dwarfs have revealed chemical traces consistent with elements from rocky planets. The Hubble Space Telescope, for instance, has detected spectral signatures of iron, silicon, and magnesium in the atmospheres of several white dwarfs, suggesting that they have literally cannibalized their former planets. Another fascinating aspect of these studies is the possible connection to dark matter and gravitational interactions on a cosmic scale. If a planet can be destroyed by its own star, could a similar mechanism exist on a galactic level, involving interactions between supermassive black holes and planetary systems? Some scientists suggest that, at the hearts of galaxies, entire populations of planets might be destabilized and driven to their demise due to the immense gravitational forces at play. In the coming years, new observational missions could provide us with even more detailed data on this phenomenon. The Japanese X-RISM probe, with its high-resolution X-ray spectroscopy, could definitively confirm whether what we are observing is truly the slow agony of a destroyed planet. This event gives us a privileged glimpse into a fate that might also await some planets in our solar system once the sun transforms into a white dwarf. Every new astronomical discovery reminds us of how fragile and fleeting our existence is, and how much we still have to learn about the universe. What appears to be a mystery today could one day be the key to better understanding the fate of our planet and other distant worlds. If you enjoyed this journey among the stars, leave a like, subscribe to the channel, and turn on the notification bell so you won't miss the next cosmic discoveries.